Welcome to Across the Globe. Today we will learn about model evaluation basics. Model evaluation is a critical step in machine learning where the performance of a trained model is assessed using new data. By evaluating a model, we can measure its predictive accuracy and its ability to generalize to unseen data. The ultimate aim of model evaluation is to identify the most suitable model for a particular task. For instance, in a spam email classification scenario, model evaluation would involve measuring a model's accuracy in correctly identifying spam and non-spam emails using a dataset that was not part of the model training process. Model evaluation metrics are crucial in assessing the performance of machine learning algorithms. Accuracy quantifies the proportion of correctly classified instances, while precision gauges the accuracy of positive predictions. Recall, on the other hand, measures the completeness of positive predictions. For example, a spam email classifier with high precision correctly identifies most spam emails out of all emails flagged as spam. Conversely, recall ensures that the classifier correctly captures all actual spam emails. Employing these metrics assists in comprehensively evaluating a model's effectiveness in various real-world applications. Cross-validation is a method to evaluate a model's performance on unseen data. It entails dividing data into subsets, training on some and testing on others. One popular approach is k-fold cross-validation, where data is divided into k subsets, and the model is trained and tested k times. For instance, in a 5-fold cross-validation scenario, data is split into 5 subsets, with the model being trained and tested 5 times. This method helps in assessing a model's generalization ability and reliability beyond the training dataset, promoting more robust model evaluation in real-world applications. Model selection is a critical step in machine learning, where various models are evaluated to choose the best performer based on evaluation metrics. The selected model should not only excel in performance metrics, but also generalize effectively to new data. Techniques like grid search and random search aid in hyperparameter tuning for optimizing model performance. For instance, in a scenario where choose between different regression models for predicting house prices, model selection would involve assessing each model's performance using metrics like mean squared error and selecting the one that provides the most accurate and robust predictions. To build and evaluate a logistic regression model in Python using scikit-learn, follow these steps. 1. Import the necessary modules. Train test split for splitting data and logistic regression for logistic regression modeling. 2. Split your data into training and testing sets using train test split, specifying X and Y data, test size, e.g. 0.2 for 20% test data, and setting a random state for reproducibility. 3. Create an instance of the logistic regression model using logistic regression. 4. Train the model on the training data using fit by passing xtrain and ytrain to the model. 5. Evaluate the trained model using the testing data by calculating the accuracy with score, passing xtest and ytest. The accuracy of the model can be obtained as a decimal value between 0 and 1. 6. Display the accuracy of the model by printing it to the console. By following these steps, you can effectively build a logistic regression model in Python using scikit-learn and assess its accuracy. Evaluating a model is like testing a new recipe before serving it to guests. Just like you taste the dish to ensure it meets your standards, you evaluate a model to ensure it accurately predicts outcomes. Understanding the basic principles of model evaluation is similar to following a recipe to create a delicious meal. By carefully following the steps in the evaluation process, like following a recipe, you can ensure your model is successful in its predictions and performance. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The Python code showcases the evaluation of a logistic regression model using model evaluation basics. Firstly, sample data is generated with features X and binary labels Y. The data is then split into training and testing sets using train test split. a logistic regression model is instantiated and trained on the training set. Subsequently, the model makes predictions on the test set. Using the predicted values and the actual test labels, evaluation metrics like accuracy, precision, recall, and F1 score are calculated. Accuracy. It measures the proportion of correctly classified instances out of the total instances. Just like in quality control processes, where accuracy showcases how many products adhere to the standard specifications. Precision. Precision indicates the proportion of correctly predicted positive instances out of all instances predicted as positive. It is akin to a manufacturing plant specifying the correct quality control measures to avoid faulty products. Recall. Recall calculates the ratio of correctly predicted positive instances to all actual positive instances. It's comparable to a medical screening test that correctly identifies individuals with a disease out of the total individuals with the disease. F1 score. The F1 score harmonizes precision and recall into a single metric. It provides a balance between precision and recall, making it useful when both are crucial. It's like finding the perfect compromise between two competing objectives. By printing these evaluation metrics, we gain insights into the model's performance, similar to conducting taste tests before launching a new product. This model evaluation process helps us ensure the model's reliability and effectiveness in real-world applications like predicting customer churn in a business scenario or detecting fraudulent transactions in finance. One industrial application of model evaluation basics can be found in the field of healthcare. For instance, when developing a predictive model to identify patients at high risk of a particular disease, such as diabetes, it is crucial to evaluate the model's performance using metrics like accuracy, precision, recall, and F1 score. This evaluation helps healthcare professionals assess the model's effectiveness in correctly predicting patient outcomes and allows them to make informed decisions regarding patient care and intervention strategies. Another real-world example of applying model evaluation basics is in finance. For instance, financial institutions often use predictive models to detect fraudulent transactions. By evaluating these models using metrics like accuracy, precision, recall, and F1 score, financial organizations can ensure the effectiveness of their fraud detection systems. This evaluation process helps in identifying and minimizing false positives and false negatives, ultimately improving the overall security and integrity of financial transactions for customers. Across the globe, industries and sectors rely on model evaluation basics to assess the performance and reliability of predictive models in various applications, ranging from healthcare and finance to marketing and cybersecurity. By employing these evaluation techniques, organizations can make informed decisions, enhance their operational efficiency, and provide better services to their customers. Keep learning, stay curious, and I'll catch you in the next video.